Hi, my name is Christoph, and in our paper we tackle two challenges in performance testing, especially microbenchmarking. The first challenge is that microbenchmark suites are often long-running, up to multiple hours or even days. And the other challenge is that microbenchmark results often suffer from high performance variability, which leads to unstable benchmarks. Through proper configuration of the benchmarks, one can tackle these two challenges, but ultimately it's a trade-off between runtime and stability, which is hard to get right. We observe that current execution configurations might waste precious execution time by running too many warm-up iterations or unnecessary forks, which do not lead to better results. And manual configuration is required for every benchmark and execution environment. So we need a dynamic data-driven way to decide when to stop microbenchmark executions. We do this by introducing dynamic reconfiguration, which decides during the execution at 2 points whether the current measurements are stable or not. The first point is after warm-up iterations to decide whether the system is in a steady state and the warm-up phase can be stopped. This is based on one of the 3 stoppage criteria. The other point is after forks, where we decide whether the overall measurement is already stable or not, again based on the stoppage criteria. Through this, we hope to skip many iterations and forks and save a lot of runtime while still keeping the same result quality. We evaluate our approach to a static configuration, which is how benchmarks are currently executed, and assess it with respect to the stability and the runtime savings. We find that in our experiments, for the majority of the benchmarks, the stability doesn't change with dynamic reconfiguration, and we can save a substantial amount of runtime compared to how benchmarks are currently executed. For more information, please read our paper under the following links.